Hello everyone. I'm making this video to make you understand statistics week 6 discussion. As a part of this discussion, a task is given which consists of a data set, and a set of 8 questions were given. These 8 questions were given. By using Excel and Excel Analytics, we are supposed to address those 8 questions. Some of the questions requires solving Excel solutions, then others require interpretation of the results. Okay, so let me start working on the document. So to make it simple, I will be providing you the solution, and I will also explain you how to interpret data and what to be written. So please follow my video and finish this task in 300 to 400 words. So this is the data set given, and let me start with first question. What is the first question? Develop a table that shows number of wines that were classified as classic, outstanding, very good, good, mediocre, and not recommended. So this is on priority basis, maybe like top one is classic, next it is outstanding, very good, good, mediocre, and not recommended, and their average prices should be taken. Alright, so for doing that, we will be using pivot charts. So I will be making a pivot table out of it and creating it. So now we have a pivot table. So let me take rating, and rating count is taken. Now you can see that some of the ratings that are used in the data set are mentioned here, and their number of times they are present on the table are also available here. Now let me take price, and this should be taken average, as it was asked to take average price. So I am taking average price. Right, now according to the given requirement, first one is classic, outstanding. I will copy this, and not recommended. These are the columns that we have. So classic, next it is outstanding. So we need to follow the given task. Very good, then it is good, then it is mediocre, and finally it is not recommended. So these are the types of ratings that we have. Oh my god. Now this is the rating, then this is count, then this should be average price. Okay, let us create a table for this. What is the classic count? It is 7. For outstanding, it is 40. Then it is very good, that is 45. Then we have good, which is 7. Mediocre, it is 1, and not recommended, it is 0. Okay, what is the average price for classic? This is equal to 269, and for outstanding it is equal to 73, and for very good it is 30.355. Then for good it is 16. Then for mediocre it is equal to 21, and for this one we don't have any detail regarding that. Okay, so this is the table that we need. And you can make your design aspects, you can design it accordingly, and you can name them. Maybe like a wine rating, you can update headings also. These details can be updated. Maybe like I am taking less number of 2 decimals. You can keep 3 decimals, 4 decimals to make it unique. Like your data should look unique, right? For that purpose I am telling, just update that one. Now this will be copied by me, and I am pasting it here. So the first part of a given task is done. Alright, so this is the table that I am created, which was asked, and I am created that. Now, what is the interpretation that we can make? Here question is, does there appear any relationship between price of wine and wine spectator rating? You can see this is bottom up approach. Classic is the best one and not recommended is the least one. So when we see the price, other than one area, most of the times the value of the price of wine, when rating is improving, it is observed that it is positive. So we simply say that there is a positive relationship between a rating and average price. If you want a better rating wine product, you will be spending more money on that. Okay, so we try to describe it here. Simply say that observing the table, there is a lot of detailing that is given, and when we take the top product, it is the highest cost, and when we take a least product, it is observed to be having a least value, and when we compare both the things, as the rating is increasing, the average price is increasing. So there is a positive relationship between both the factors, which means that if rating increases, price increases. If price increases, you can get a product that has better rating. Very simple. So now you need to write it here. Okay, you are supposed to give your interpretation here. So ignore this question. If you have anything, only thing that is that matters is considering good and Medicore. There is small mismatch here. Usually when we have Medicore 21, as we have good 16.71, the rule that they both are positively related will be failed here, because good is having lower rating than Medicore. So that is the only issue that should be identified. Sometimes data consists outliners, so we can ignore that. Okay, so next task is developing a scatter diagram with the price on the horizontal axis and wine specter on the vertical axis. Does the relationship between price and score appear to be linear? So now we will be evaluating the data, these two factors, and we want to explain how price and score are related to each other, whether they are positively related or negatively related, or there is no relation at all. So we need to comment on that. So for that he was asking us to create a scatter diagram. So I have prepared a scatter diagram here, and we can see that there is a trend line that was created here. So you just double click on this one, you can make any design related selection, any new and unique design selection, and copy paste that diagram into your document. So now I have this diagram here, and what I can see is there is when we draw a linear diagram, it is scaling up. It means that when the price is increasing, the wine rating is the wine score is also increasing. So there is a positive relationship between, because the graph is going up, so it clearly explains that the relationship is very positive. Okay, so there is a linear relationship between price and score, and the relation is positive. The data is positively skewed. Okay, that information should be provided here. So very simple thing, it clearly explains how these two values are related to each other. When we have 0, what is the when price is 0, when wine score is 0, what is price of the product. Based on that, we create this scatter diagram, and we can easily establish relationship by using the trend line. The trend line clearly shows that it is going up. It means that both the factors are positively related to each other, which explains that when when wine is increased, price also, when wine score increases, price of the product also increases. The data is positively skewed because most of the data is towards most of the data is data interrelation is related to each other, so it is very much positively skewed. So next one, it is using linear regression, develop a estimated regression equation. Can that be used to predict the given score of the wine? So right. So let me start. So I have created this one. So this is a linear regression equation for these three factors. So we will be calculating score by using price value first. So the relationship between price and score is, you can take this equation, y is equal, means score is equal to 87.76 plus 0.27 into price. So this is the equation. This equation you can straight away copy paste into your document. This is the linear regression equation. Okay, now can we predict about score using these values? Yes. So we can predict. How you can predict? Let us take an example. Okay, so you assume your own value. Here I am assuming price is equal to 10. Let me assume. You write in your own way. So I'm just giving an example. Let us assume price is equal to 10. Then what happens? Score is equal to 87.76 into 0.27. Sorry, this is plus 0.7 into 10, which is 87.76 plus 2.7. Therefore, score is equal to what it is, 90.03. This becomes 614. .46. So it clearly shows that when we have value of price, there is a possibility that we can predict about the score. So the linear equation helps us to predict the score. Okay, so this is equation, and you are supposed to take an example as it is possible to predict. We make an assumption, we calculate it, and we prove that it can be calculated. Next, we will be creating second order model. The second order model, what we do is we make a square of this one. So means 52 into 52. 52 square will be used here. Squared values means order 2 values are developed, and we use multiple regression to create this linear regression equations. Okay, so what is the equation here? Here again, score is equal to 86.166 minus, sorry, there is a plus here, plus 0.07 price minus 0.00011 price square. This is the linear regression equation that is created out of multiple regression that is performed. So now that can be used to predict the given score of the price of the wine. Yes, it can be used because we have linear regression, and we can predict about it. Let me take the same example. assuming 100 as price, so this will become 0.07, right? 0.07 into 10 minus 0.00011 into 10 square means 100. This will be equal to 86.166 plus 0.7 minus 0.011. And now use your calculators, that would be helpful. 0.011, this will become 551 155 155 minus 75 85. So decimal is 85 and this is 86. So this clearly shows let me do it again, I made some mistake here. 86.866 minus 0.11.011, this will be 86.855. okay, this is the answer. So it clearly shows that we can predict the value using second order linear regression equation, and hence we concluded it. Comparing the two linear relations and fitting related information. Now here we have two details. This is summary of regression statistics we call. We need to compare these two things. So first thing, if we cross check multiple R, which speaks about correlation. So when price and score are explained, there is a correlation which is 0.63. So having high correlation makes better results, means like it will be giving higher accuracy. Okay, when we have good correlation, it will be providing higher accuracy. So you can see here for second order linear regression we are having high correlation, so second order one is the best option to perform prediction. Okay, the predictions that are made using the second order will be generating better results. So both are having good fit, but when compared to the first order, second order is providing better results. Next one is R square value speaks about accuracy, means for example when we give 30 value, so when the value is 30, if you predict 30 exactly, it is 100% accuracy. If you predict somewhere nearby, it will be a wrong selection. Okay, it is not an accurate value that is predicted. So when we compare, like when we use all the 100 values to compare it, it was identified that approximately 52% of times the value was predicted approximately, exactly, and remaining all the times it is the problem. So it is not able to generate it. So here the accuracy is 52, and here only 40 times it is calculating perfectly. Here accuracy is 40.6%. So considering the accuracy, it is possible to say that the second order is very much fit when compared to the first order, because its accuracy R square value is lower compared to the second order regression. Okay, so we compare these things and we conclude about which option is best one, normal linear regression or second order linear regression. Okay, we write about it and we conclude fifth statement. Then as an alternative fitting a second order model, fit a model using natural logarithm. Okay, natural logarithm is created using a scatter plot. So here it is created, and we can see that the R square value, we have created an equation. You can copy this equation, copy, and you can paste it here. Let's just use this one, unformatted unit text. So this is the equation, and from the equation we can see that the r square value is 57.58. So whereas here second order value is, it is 52. So which clearly shows that logarithm, natural logarithm of price is giving a better r square accuracy value. So which explains that this one is more fitting model when compared to second order model. Okay, so fittings explains that how the data is distributed, properly distributed or not. The data that is used in the analysis is having the ability to establish some good relationship between variables, and it helps us to predict about some variables or not. That will be explained by performing fitting activity. Okay, so here logarithmic, natural logarithmic of price as independent variable, when we take it like that, it will be providing better results. Okay, so you are supposed to explain that, means you will be writing 2 to 3 sentences of explanation on that. So now finally, in the 7th question, what we are doing, based on your analysis, what would you say? Spending more for a bottle of wine will provide a better wine. It is true, right? From the analysis we can clearly see that you have a regression table which clearly explains that when we give some value, higher value, it will be providing better wine when we spend more money. From first question onwards, at every stage it will be clearly showing that when we spend more money, we will be getting better wine. So simply 1 or 2 sentences conclude that. Then we have suppose that you have to spend a maximum of $30 for a bottle of wine. In this case, will spending closer to your upper limit of price will result in a better wine. So for this one, you just take, you try to take value of, let me take value of price, maybe price, let me take price 10, 20, otherwise 5, 10, 15, 20, 25 and 30. Now let me implement it in a linear regression about score. This is equal to 87.76 plus 0.27 into price. Now we see, when we have a price of 5, the score that is achieved is 89.21. When we have the price of 30, the score of the wine that we are purchasing is 95.96. Now if we see, as the price is increasing, the score of the wine is also increasing. It means that when we increase, we have $30 budget, and when we start increasing our budget, the quality of wine also increase. The quality of wine that we can purchase also increase. So it can be explained clearly that as the price of the product increases, the quality of the product also increase. Okay, in that we can explain. Spending closer your upper limit will. So this question is clearly addressed, right? As the price increases, definitely quality, better wine, possibility of purchasing better wine for lower price also increase. Okay. So now we addressed all the 7 questions, and after addressing the 7 questions, you just save your document and forward this whole document to me. All right. Thank you, team.